Salam alaikum. This is Muhammad Ashraful Haq, an assistant professor, Daffodil University, and a PhD student in University Technology Petronas, Malaysia. And the topics of our presentation: development of high-gain broadband MIMO antenna for 5G wireless communication based machine learning verification. And our team is Muhammad Ashraful Haq, Mr. Sharif Ahmed, Mr. Redwan Al Ananto, and Dr. Samit Selim Al Bauri. So the table of the content is the abstract, design of the proposed antenna, result analysis, prototype and measurement, and the simulation result of the proposed antenna, machine learning methodology, validation of antenna results with machine learning, and the conclusion. So the abstract is that the presentation presents the finding about the implementation between the machine learning and how the antenna is optimized to the 5G application and how it will be integrated with the machine learnings, and the validation of the simulated antenna with the measurement results. And this is our design process. There are 3 steps. First is single element, second one is the array, and the third one is the MIMO antenna. And the designing process is that first we have to consider for the single element for the 28 gigahertz, and then we are consider for the array to improve our the gain, and also considering our the equivalent circuit RLC and the validation the result, and finally we use the machine learning technique for the gain prediction. And this is the result analysis. Figure A is the result between the comparison among the single element array and the MIMO, and the right hand figure are the comparison among the gain of the array MIMO and the single element, and also the efficiency of the single element array and the MIMO. And this is the result analysis. So this is the one of the biggest thing is that the bandwidth is very high, 2.078 to 4.855 gigahertz, and the gain is also very high in the 7.48, and also increased when in terms of the array is 10.34 dB. And this is the prototype and the measurement results. In the left side we measure the results, the radiation characteristics with the Anquick chambers. In the right side we also measure the return loss and the radiation patterns. And these results are the validation of the simulated and the measurements S11 simulated versus measured. And the second figure is the mutual coupling of the proposed MIMO. This is the mutual coupling for the second figure. And the third figure is the gain and efficiency. For the gain is the mark is the red, and the efficiency mark is the blue color. So these are the result analysis for the simulated versus proposed results. And the prototype and measured results are also the same, and measured isolation is better than the simulated isolation, and measured gain and efficiency drop little bit compared to the simulation. These are the summary of the results. And after that we are also going for the RLC equivalent circuit. So there are so many figures. The figure 7 is the RLC equivalent, and the figure 8 is the total MIMO RLC equivalent circuit, and the figure 9 is the reflection coefficient of the ADS and the CST. And these are the machine learning technologies. This is how we can extract the data from the CST, and also designing first antenna in CST and then export the data CST, and then they prepare the data set for the machine learning. These are the flowchart for the machine learning. And the second thing is that how we train the data and get the evaluate and predict the results. Training data is with 80% and testing data is 20%, and finally we evaluate 5-6 models, and finally we got the our desired prediction results. And these are the validation of the simulated and the predicted results. This has been seen that the gain of the simulated and the predicted result is almost similar, and we have been noticed that the Gaussian process regression is the best machine learning results, is the regression model, which has been shown that this is the best results of the gain. And the red color has been shown in the simulated, and the blue color has been shown in the predicted. So the key features is it has been working in the 28 gigahertz resonant frequency, which is 5G, and also 4-port MIMO antenna. High isolation gain is also very high, and efficiency is also very high, and the size is very compact. And the application is 5G wireless application. It has been working, and the fixed wireless access it has been also working, and vehicle to everything V2X is communication is also been working, and also industrial automation and in Internet of Things and the satellite communication. So finally the conclusion is that we can say that this is very good working, as efficiency high, isolation is very high, and also for this reason it is very suitable for the 5G applications. Thank you for Salam Alaikum.